Steel is a versatile and widely used material in various industries. It is found in industries from construction to automotive manufacturing. One of the fundamental properties of steel that makes it indispensable in industrial applications is its density. Knowing the density of steel is crucial for engineers, architects, and material scientists who work with this remarkable material. In this blog post, we will discuss the following: the concept of density, the density of steel, the significance of steel density, and many more. Density is a fundamental physical property of any material. It provides a measure of how much mass, or matter, is contained within a given volume. In simpler terms, it tells us how tightly packed the particles or molecules of a substance are. The density of a material is defined as mass per unit volume. The formula for calculating density is where ρ represents density in units like kilograms per cubic meter, kg per cubic meter, pounds per inch 3, pound/in cubed, or grams per cubic centimeter, g per cubic centimeter. M represents mass, typically measured in kilograms, kg, pounds, pound, or grams, g. V represents volume, usually measured in cubic meters, cubic meter, cubic inches, in cubed, or cubic centimeters, cubic centimeter. Steel is an alloy composed primarily of iron, along with varying amounts of carbon and other elements. The density of steel can vary depending on its composition, but the most common type of steel used in construction and manufacturing is carbon steel. When purchasing steel pipes or any other industrial steel material, the density of steel plays a vital role. With an increase in density, the weight increases, which increases the cost as most materials are priced based on their weight. There are various types of steel, and the density of each type of steel varies depending on their chemical composition. Also, the density of steel is not constant. Various parameters affect the density of every material. Some of the factors that impact the steel density are manufacturing technique, alloying elements, raw materials quality, grain structure, heat treatment that is performed on steel material, rate of cooling during solidification, the temperature of the material, and pressure. The density of carbon steel typically ranges from 0.28 pounds/in cubed to 0.2908 pounds/in cubed. This means that for every inch 3 of steel, it has a mass of approximately 0.28 pounds to 0.2908 pounds. Steel density in pounds/in cubed and kg per cubic meter for some of the popular types and grades are provided in Table 1 below. The density of steel in pounds/in cubed can easily be converted into kg per cubic meter by multiplying by a factor of 27,679.9, as 1 pound/in cubed equals 27,679.9 kilograms per cubic meter. The density values in kg per cubic meter for different types of steel types and grades are provided in Table 1 as well for your convenience. In a similar way, if you know the density of steel in kg per cubic meter, you can easily convert it into pounds/in cubed by multiplying it with a factor of 0.0000361273, as 1 kilogram per cubic meter equals 0.0000361273 pounds/in cubed. The density of steel is a crucial property that holds significant importance across various industries and applications. Here are some key aspects highlighting the significance of steel's density. Structural integrity. Steel's high density contributes to its exceptional structural strength. This property is particularly valuable in construction, where steel is widely used for building structures such as skyscrapers, bridges, and stadiums. The high density ensures that steel can bear heavy loads, resist deformation, and maintain its structural integrity over time. Weight efficiency. Steel's density is a key factor in achieving an excellent weight-to-strength ratio. This means that steel can provide substantial strength while adding relatively little weight to structures or components. This is essential in applications like automotive manufacturing, aerospace, and shipbuilding, where minimizing weight is critical for efficiency and performance. Durability. Steel's density contributes to its exceptional durability. It can withstand extreme temperatures, pressure, and mechanical stress, making it ideal for use in challenging environments. This durability is particularly valuable in industries like oil and gas, where equipment must endure harsh conditions. Safety. Steel's density also plays a vital role in safety applications. For example, in the manufacturing of safety barriers, fences, and protective equipment, steel's density ensures that these items can withstand impact and provide the necessary protection in various scenarios. Versatility. The ability to control and manipulate steel's density through alloying and manufacturing processes allows for the creation of specialized steel materials tailored to specific applications. This versatility makes steel suitable for a wide range of industries, from medicine to electronics. The density of steel is a fundamental property that underlies its strength, durability, and versatility. Engineers and scientists rely on this property when designing structures, vehicles, and various industrial equipment. Steel's remarkable combination of high density and strength has made it an essential material in modern society, contributing to the construction of safer, more efficient, and environmentally sustainable infrastructure and products. As technology advances, we can expect steel and its alloys to continue playing a crucial role in shaping our world.